All right, cool. I see Jonathan. We have you on the call.
Yep, I'm here.
All right. Luckily, the schedule's getting a little it's shifted anyway, so you fit
Yeah.
in perfectly. If you'd like to go ahead and give your PySat update, I'll make sure to get the link to the general notes in case folks want to do that with me at the same time. But you're free to present whenever.
Is that working?
Yes.
Okay. Great. Yeah, so sorry didn't make it yesterday. Had a bit of a bout of confusion, I guess. But I'll be giving the PySat updates today. So Angeline put these slides together, Angeline Burrell at the Naval Research Laboratory, and then I'm presenting on her behalf. I'm Jonathan Smith. Also on the development team, currently we have Russell Stoneback, who is working out of Cosmic Studio. So this is just a quick rundown of the sort of current status of PySat. I won't get into a lot of details, but development has been a little slow and sputtery over the last year or so, but we have managed to get out some updates. So here are is a list of stable releases. You can find out more information, more detail on all of these releases and what is currently happening with them at this link here. If you just go to the PySat GitHub and find your way over to the wiki, there's an ecosystem status chart that has information on all the sort of the library packages for PySat. The yellow dots indicate that there have been new updates since the last PySat or PyHC meeting, and then the dark circles mean there's been no change, but those are still stable releases. So in March, we pushed out a new PySat core package version 3.2.2. PySat NASA is there's changes in the develop branch, but nothing new to the stable version updates. PySat space weather, we got some updates in October. PySat seasons. I guess I'll go into a little bit more detail as I'm giving these updates about what each of these packages are. But the PySat seasons, there was an update in November, and PySat Madrigal in March, PySat CDAC in February. So move on to the core package. So the main PySat package that handles all of the file management and sort of data structure work. We updated the PyPy distribution to include a little bit of test data. Um, that's mostly there for developers who want to make changes and have the unit tests work fully. And then we updated the documentation to keep all of our affiliations and references up to date. And we were supporting all the way down to Python 3.6, but our operational environments, we were able to convince those teams to bump up their versions to 3.9. So now we can at least drop 3.6 out of our unit testing.
Quick question.
Yeah.
So what are some of your operational environments? I'm just curious, your audience.
Yeah, I'm unfortunately not the best person to take that question, but I know at NRL they are using PySat in a space weather prediction context. So I think they're mainly using the core package, and it's out of date now, but they're using PySat space weather. And I don't know a lot about that because that's an internal NRL operational environment.
But you have good communication with them. I mean, I just think it's great that you're able to find out which Python versions your user base are
Yeah,
using.
I mean, it helps because Angeline's there, right? So she's the main contact for that. She's at the Naval Research Lab, and they're the ones that set that up. So I don't know everybody on that team, but I'm pretty sure like Kate Zoddy um, and Doug Draub are working on that as well. So yeah,
Okay.
that's
Were they the major driver for Python 3.9, or did you get feedback from other operators of, hey, please don't advance Python? 'Cause, that's an issue we're all hitting.
yeah. I mean, I think they're the main one. Most of the other teams that we work with are pretty happy to stick with the spec 0 limits usually. So that's nice. But yeah, that was a big one because they have a lot of other, dependencies that they have to maintain, of course. So
Awesome. Thank you.
yeah. So I'll just move on to PySat Space Weather. So this is basically just our plugin for the Space Weather Prediction Center. And they made a bunch of changes to the way their files are formatted and locations because of changes at NOAA. And so we had to react in kind. So we updated that. For this package, we were able to move up the lowest supported Python version to 3.10, and we introduced testing for 3.13. So trying to stay up to date with all of these packages. PySat Seasons, which is like just a seasonal analysis research tool chunk of PySat, just needed a maintenance release. Functionally, there's no real changes, but it was a little out of date in terms of its unit tests and the CI, the continuous integration workflows. We changed our setup to use a PyProject TOML. Dependencies were out of date, and we improved the documentation a bit because it had been sitting for a while unaltered. PyStat CDAC, which is our chunk for dealing with the Cosmic 1 and Cosmic 2 data sets. Again, this is just a maintenance release, so just trying to keep up to date with the PyHC standards, updated our workflows and our Spec 0 tests. There was some clunkiness in the X-array implementation that's been updated, out of date dependencies and dependency conflicts. And then this one is used in some some production environments. So again, this one we could only bring it up to 3.9. So that's the updates on the main stable packages. Here's sort of a overview of these packages and where they're at, and some upcoming improvements. Things with pull requests that are under review currently. So we're going to add some more indices from the Space Weather Prediction Center. We're going to include the new MG2, well, maybe not that new, but the MG2 solar indices. In PySat NASA, we have been working to get the tidy data included there. That was a request. I forget the person who was requesting that, but that's for one of the other operational environments too. We are including more of the Cosmic 2 data products, so specifically in expanding to the GPS data products, because I think at the moment we're mostly using the IVM for CDAC. We have the PySat missions package, which is all about sort of mission planning, sort of like a really low resource, quick look for planning out orbital mission, satellite missions, so you don't have to work through GMAT or STK or something. And then the PySat Magical package is just a little out of date, and it's going to get a maintenance update pretty soon here. So it's the big look at upcoming work, and that is it. I'd like to acknowledge that Angeline Burrell is supported by the Office of Naval Research, and we want to give a special thanks to Jeff Cleansing, who has stepped down from the development team this year. He may be coming back at some point, but for now, he's off to different things. If you ever want to get in contact with the PySat team, there's always the PySat GitHub, but then we're all on the pysat.developers@gmail.com, so we'll all get that email. So you can blast a question to everybody that works on PySat all at once. Yeah, that's it. Thanks so much.
Thanks, Jonathan. You have a comment or question?
Yeah, I got one. Nice talk. It's great to see things, continuously being improved. one of the things that the Happy team is trying to do is to help make it easier for you to not have to do so many upgrades. Like if we could convince Noah Swipsy to use a Happy server, then you stop worrying about what formats they have in their file.
Right.
So, um, I, you know, we may try to, or I'm not sure what my question is. Can we use you as leverage with them to try and get them to do it? It's like,
Yeah, maybe. Yeah, because we've talked about it, and like we're already happy to start working more, I mean, less sort of on our own, so I've siloed. We've been working like the PySat NASA package because I work with SPDF a lot as a data curation scientist. We've been integrating more and more their work in here. So I mean, we use their web services.
right. And they have Happy now too. So,
I'm happy now too, exactly.
yeah. So if you can eventually get access to their stuff through Happy, then that's one less set of custom interfaces that you have to keep curating.
Mm-hmm.
And
That's right.
yeah.
Yeah, I will definitely bring this up at the next PySat meeting. Yeah, because we do have maybe some contact with some of these people, so maybe we can convince them.
Yeah, I mean, we're just looking for the community to start exerting pressure. It's like, hey, why aren't you using Happy yet? Not because, I mean, it's okay, it's self-serving, but it's like also it really should be easier than what it is, right? Everyone's got their own custom thing, and it really causes these maintenance headaches.
Yeah, it does.
So,
especially when, because we get the reports from users that there's
right.
something down. It's like we don't use all the packages all the time ourselves, so
Right.
it's
Yeah.
it's hard to know when something breaks. So who knows how long that was broken, and
And it's a branding thing too, right? Like the PySat brand is hurt. Oh, PySat doesn't work. It's like, well,
exactly.
it's not our fault, actually. I mean, okay, ultimately it is like if a Happy server doesn't work because something broken. Well, it could be the server maintainer's fault, but you know, we as a Happy community have a responsibility to try and help maintain the integrity of the whole ecosystem.
Yeah,
And same for PySat, right? Like if PySat it doesn't work, that hits you.
exactly.
So finding ways to make this better. So yeah, any chance you get, you tell them, hey, try to use standard stuff. Don't change your thing. Try to make it easier for the whole community.
Yeah, for sure.
And if that involves saying, hey, if you used Happy, a lot of these problems would go away. Just I'm telling you, that'd be great if we saw that.
Yeah, I like it.
Yeah.
Hi, Nick has a comment.
Yeah.
Yeah. Fair enough.
Yeah. The other thing to mention, oh yeah, is that like the other thing we're trying to do next with Happy, I mentioned this yesterday briefly, is like for magnetometer data, what if there was a schema that if people say, oh, that not only this is available with Happy, but this data meets the following schema, which is for ground-based magnetometers. And now all ground-based magnetometers could say, oh, hey, I'm compliant with this schema. You get it through Happy, it meets a certain schema, and so I know exactly what to do with that data. I can treat it like identical ground magnetometer data structures from all these different sources. That's kind of the next level we're shooting for. Um, and you could do it we might do simpler things first rather than science data, but like an event list. This was super popular at Dash. Let's have a schema for event lists so that everybody's happy based, or it doesn't have to be happy even. Here's just a schema for event lists and people can conform to that. And then everybody's event lists can be digested by the same parsing mechanism. It's like,
Yeah.
wow, that would already be really cool.
Yeah, definitely.
Yeah. All right, I'll get off my soapbox. It's probably smashed by now.
We appreciate your soapbox. Do you have any other thoughts or comments? All right, 5 seconds have passed. That means no. Well, thanks, Jonathan, again for the update.
Thank you.
Hopefully, Angeline can come back to work in a more normal capacity soon. All right, well, the next presentation will not be for about 10 minutes. We have a Helio data update on the agenda, and I know Tressa and Wale are supposed to join around then. So, Rebecca, did you want to say a piece about licenses? We have a few minutes. Yes.
Sure. Okay, so we have two chunks for licensing. I put a link to the relevant comment in the chat. So this is really related to FEP 6. I don't think John Niehoff is on.
No, he has an IMAP meeting he can't get out of.
Okay.
Your screen came on, but it's totally dark.
Hi.
There.
Thanks. I forget that thing sometimes.
Yep, there you are.
Okay, so we have two ideas for these licensing thing. So if you follow the link in the chat, that goes to this comment I created last night. Well, the current text on FEP 6 prefers the BSD3 and Apache 2.0 for all packages in the gold tier. We are in the middle of drafting some policies to support research artifacts at HDRL. I'm not going to give more details right now, but it would be very good for us to hear from the PyHC community what are the preferred licenses. So I'm asking again because at the fall meeting last year, from the perspective of the Heliophysics software search interface, we acquired a list of licenses for software, and that's in the comment right there. And all of the links lead to the text of the licenses. However, there are licenses indicated in this FEP 6 that aren't on that list, and there are licenses on this list that aren't in FEP 6. So what I'm interested in is a list of the software licenses preferred by this community, so that HDRL can consider aligning with that preference in our archival policies. There, go.
Well, can you share your screen?
Oh, sure. Okay, let
I
me
pulled
grab
up that
these.
link, but it's probably easiest if you're talking right to that. Like, here's the list. Is that enough?
Okay, I'll go for it then.
So I saw the comment. Is the main question you're asking about then for the HDRL purposes or for the purposes of what's included in FEP 6? Just want to make sure.
FEP 6. So I brought the comment up a little farther up the chain, and then Jim Lewis, you had a comment about how, PySpeedS is the MIT license. So why should we exclude that, or should we include that in the gold tier, for instance? And now that we're talking, are there good reasons we should exclude any of these licenses from gold tier? Or was it just, hey, we didn't walk through it before?
I asked John if he had any thoughts he wanted communicated, and he gave me a little bit more context. I can give that now. So the idea was to give people with a free choice of license to have a very, very short list. Kind of the way it's written, it's use this unless, and unless in John's mind was very broad, with the reasonable set of unless being larger with more reasonable license. I guess the idea being, if someone has a free choice of license, should they get a really long list of possibilities or a really short one so they don't even have to think about it, kind of thing. So that's, I guess, where he's coming from as to why he put a shorter list initially.
Yeah. But the way this looks externally is that only the BSD3 or the Apache licenses are really the preferred licenses. So if there is a longer set of licenses that are preferred by this community for the gold tier, then that will be useful externally.
Sure. What are people's thoughts? I'd be fine with MIT, especially being in that list, because I know it's a common one. It's not restrictive.
So you're just wanting access to the longer list of OK licenses for HDRL purposes.
Well, this is bigger. So the NASA funding people, to phrase it badly, I guess, they look to the PyHC standards as the thing to ideally require of software for the software funding opportunities.
But this is just Python, right? So you have to be a
Right.
little careful.
Yeah. Yeah. Um, Distinguishing between what's good for Python and what's good for Fortran, I feel like is beyond the scope of this meeting.
Well,
But
but
if
there
we can
are
at
others,
least start
Java,
from Python.
Julia, R, other and new ones that we won't don't know about yet. I mean,
So if there are, so the idea is to, from what I understand of context here for PyHC, PyHC wants to encourage licenses that don't restrict downstream use and don't restrict collaboration. Um, so if any of these licenses do restrict downstream use or they do restrict collaboration and someone already knows about that, speak up. Right? Like those should absolutely be excluded from preference for PyHC. But if all of these are generally fine, and maybe also the ones that John highlighted in the text for the FEP itself, a little farther down that I have highlighted, that's useful information. But I do appreciate the desire to have a shorter list. I also think that list should be short, maybe five-ish kinds of things. Please don't give 20. No. But interested in some conversation there.
Just based on what I see most packages use, to me that short list makes the most sense as, like he already mentioned, Apache and BSD and MIT.
So adding MIT to that and then calling it done.
That would be my initial gut reaction thoughts, just from what I've seen, but does anyone hotly disagree?
I'm still kind of curious if there was something specific in the MIT license that prompted John to leave it off the list, or if it was just like he just wanted to pick, a very short list and didn't make the cut. Because, we would consider changing if there's, if it's restrictive in some way that we wouldn't want.
I vaguely recall talking with him about this at Dash, actually. I don't think there was a specific huge reason against MIT. It was more about keeping the list really short. Elliot, you should confirm with him on Wednesday, but that's what I recall.
So I guess what we could do here is just treat this as kind of a preview for the topic that I'm intending to bring up Wednesday when we're talking about FEP 6. So the link's in the chat. Please, if you have an opinion or you know someone that does that isn't here, send them that link and ask them to comment on it. And that can get the discussion going to get this settled for FEP 6.
Does anyone else here use a license that's not BDS3 Apache or MIT? I'm just curious.
Presumably Apache 2.0.
Yeah, sure. I guess he did specify which one.
Well, he has the link to 2.0, but he didn't say it. Little things, right?
well, that's something that what Jim's comment of, oh, we'd be willing to change this if people needed it. That's useful information, right? Because um, a lot of these packages are released with a particular license just because, oh, that's what people are familiar with, that's what they've used, but they don't really care. And so if they're willing to change it for somebody, that's useful information too. Like, are you committed to this one only? So that could be like another column in the thing, potentially available with other licenses upon request. It's like um, that's especially true for things like GPL, where it's because that one maybe we should. I mean, that's pretty restrictive. Like it's the viral ones, right? You can use this software as long as you license yours under the same licenses. And NASA recommends not using those, right? So maybe those should not be on our long list. We cannot use it at APL, for example. It's like, because it's too restrictive or it's too, I don't almost want to say like arrogant in its open source insistence, right? That everything has to be open, have this license that incorporates it.
Can you add a comment to that effect on the GitHub discussion? That would help.
Okay.
Great.
Well, yeah, in the meantime, I echo Rebecca. Make sure to hop on GitHub if you have thoughts or want to advocate for something else. Same with all the other FEPs, actually. There was a whole list that John threw. Notes that I shared from the very end of yesterday's meeting. We're voting on FEP 3 for the second vote. That's the Spec 01. FEP 4 for tiering. FEP 6, which is this licensing one. FEP 7 documentation. And then having some discussions about a couple others that John's been crafting, as well as an annual review of FEP 1. All right. Well, at this point, we're just waiting for Wale and or Tressa to hop on so we can talk video data. Let's give it a quick 2-minute break. Pause the record.
Great. Share screen. Are you able to see my screen?
Yes.
Sorry for the infinite window. So today we are going to be talking about Elio Data, which is the brainchild of Daniel Da Silva. And basically it's a site for where we have it's a unified site for heliophysics data discovery. And you can reach it by going to elio.data.nasa.gov. Right now it's in beta. As you can see, the banner shows that. And basically the need for this site is just to, to have a nexus for reaching all these data sets out there and to empower researchers to be able to perform their research in an efficient way, basically. And the idea, one of our goals is to not only help the researcher accelerate data discovery, but also to give them the option to explore other data sets they're probably not looking at. So I'm just going to go through what we have at the moment, and if we have some time towards the end of this session, I can show you what's coming up in a few weeks. So now I'm just going to kind of scroll down and show you the overview of the site. So we have the main search functionality, we have a browse section, we have an access section where we have a user guide, the missions that we're looking at or that we have data for, and then some instrumentation info. And then we have some links to some other third-party services. And then, of course, we have the footer. And you can always contact us by just clicking on that. So let's start with the search tool. So basically, what you can do is you're looking for some data, right? And you have some keyword that you want to use. So for example, let's say we use solar wind here. And we can search for that, and it gives us, lots of data. Data of interest or data that is kind of attached to that keyword. And now you can go into the facets and kind of, filter out the unwanted data sets so you can reach exactly what you're looking for. For example, you might be interested in IBEX data sets, right? So that cuts down the initial results down to 93 counts. Okay, now you can go in. Okay, maybe you're interested in instrument and data sources where maybe you're looking for the IBEX spacecraft position. Then you just focus on that, and that kind of cuts it down to exactly what you're looking for. And if you look to the left, right below refined search, you can see that it also shows you the logic that we're using to kind of filter this large data set results. And of course, you have other facets that you can use to basically filter through the results. Okay. Again, we can search for what do you want to search for? We can search for maybe ACE. We can focus on a specific mission, right? And then that, kind of shows all the data sets relating to that mission. Now, if you look to the left, you can see other missions also available. And this is because some data sets might have data from ACE and also data from MMS. So there might be some kind of intersection of data of information there. And of course, once you search for a mission, and if there's a mission that exists with that keyword, it shows you like a summary of that mission. You can click in to kind of read through the mission. And then it also shows you like a thumbnail of what the satellite might look like. All right. And of course, we have a quick search field that helps you again to focus on what you're looking for. So maybe we're looking for MMS. Now you can see, if you look to the left, we have only results for MMS. Again, you can go in, use another field to kind of focus on the data set you're looking for. If you look for AIA, that has to do with the SDO mission, and you can see it focuses straight on that. And we have other fields that you can kind of use to kind of filter through the data set results. All right. So let's take a look at one of these data sets and see what other things we can kind of accomplish by focusing on a specific data set. Again, you have the data access section where you can basically look at, okay, where other places you can get the data from. Okay, so now I've clicked on the SPDF, but depending on the data sets, you have different kind of links in this box. Okay, and also if you look down here, there's a summary of the data sets, everything relating to the data set. So things such as time resolution, the start time, the end time, the authors, published dates, all of that is in here. And of course, you can move to the next tab, and that shows you all the variables on CedarWeb that you can basically, all the variables that you have data available for on CedarWeb. And then the next tab, we have access by API. So you can use Python, you can also use IDL to kind of, if you're working with using a program, we show you a sample of the code that you can use to kind of pull data relating to this. Of course, there's the citation as well, and then there's the documentation. So I can show you an example of how we can use CedarWeb here. We can get plots from CedarWeb. So if you look at this, we have all the variables there, and it's a lot. Again, going with the goal of accelerating how you get to data, we decided to include some kind of filter field here where you can kind of get to the data faster. So for example, I'm able to filter based on this keyword PROT, and that brings out everything related to that. So that cuts down the number of variables. We can make a selection, we can set the date, and then we can plot the data. Okay, and we can have multiple plots on this model and switch between them as well, right? We have this and we have the other one as well. We're able to also download and then you can use that in a presentation or whatever, whichever way you want to use it. Okay. So we also have access to Helio Viewer. For example, if you want to get an image from Helio Viewer, we have that functionality as well. For example, you can visualize data, make your selection, you set your time, you set the instrument and the measurement type, and then you can find image. Of course, you can zoom in. But if you need more tools from Helio Viewer, what you can do is you can also we give you the option to open this in Helio Viewer. So that sets the time for you. It's already pre-selected. It just takes you to the image. And of course, you can play with all the tools they have on this site. All right. So that's a quick summary of the search tool, and also again going with the goal of giving the researcher the option to explore. We have this section where you can browse by region. We have the solar environment, we have the interplanetary space, we have Earth magnetosphere, we have the Earth's atmosphere, and we have the planetary magnetospheres as well. You can click on any one of these, and this takes you to the regions page. And of course, you have the main region, and each main region has sub-regions. For example, you can, I guess a good example would be, you have the interplanetary space. You can look at Helios sheath. You can look at the solar wind. If you were in solar environment, you can look at the solar interior, the photosphere, the chromosphere, the corona as well. And of course, if you look below that, you can see that we have two tabs here, where the first tab shows the missions associated with this region, right? The main region for now. And then you have the data sets associated with that region as well. Of course, we can go into any of these sub-regions and then see, again, more data sets associated with that specific region and the missions as well. And this goes for the rest of the sections. So you have Earth's atmosphere and, magnetospheres of the planets and also of the Earth. Okay. Now the next section is we have a user guide, we have the missions and observatories, and of course we have the instruments info. So the user guide just basically shows you how to use the site. It shows you how to use the search tool. It talks about the search results page. You can use the facets, and how you can basically filter your data sets. And then, so you can go through that if you just want to understand how the site works. And if you have any kind of feedback that you want to give the team, you can always just go go to contact, and that takes you to this page, and then you can fill in your name, your email, and your message. And then we have links to mainly the Scientific Visualization Studio, the SVS, where you can go in and kind of get various visuals that might be of interest to you. And of course, we also have a section up here and also down here where it shows you the missions and observatories that are currently in our server. Right now we're still working on this page, but we have a lot of missions in there already. So right now it says you have 471 items, but that might change as we continue to work on this page. Again, we have the filter functionality to help you to get to your mission of interest quicker. For example, if I'm interested in Soho, right, that cuts down the table, and you can easily go there and kind of get the data that you're looking for. So I think this is what we have for now. Sorry?
Hi, it's sorry, everyone. Late. I've listened to Wally's presentation, and he's doing, he was the developer on the site, so he was perfect to do the demo. I have a question. Did you talk about the access methods once you refine your search down to your data set? Did you talk about like HTTPS versus API versus FTP?
Yes, I did.
Oh, okay. Thank you.
So this section and
yes,
access up here. Yep.
Thank you.
Yeah, and so that's a quick demo of the site itself. I can just give you like just talk about the technical stack for this site. So basically for the front end, we're using React, which is like a JavaScript library that really focuses on using components to build the front end. And then the back end is built using Django, which is like a Python web framework. And then for the search engine, we're using Solr, which is basically built on Lucene. Lucene basically is a Java library that really helps with indexing information and also helping with search capabilities. And of course, building Solr on top of that, you can use that, makes it so building Solr on top of Lucene makes it possible to basically to use an API to kind of communicate with Lucene, which is the underlying technology. And then for the database, we're using Postgres. And but if we have more time towards the end, I can show you more of what we're working on right now, and so you know what to expect in the future. And Tressa, I pass it on to you.
Well, thank you so much, Wally. Did he mention that the deployment date is December 15th in time for AGU? And I'm sure he covered everything that I would have covered and more. Did he talk about, I'm not sure he talked about that the data is derived from SPACE records, which mostly rely on data from CETA and from the FStack database. I'm just going over my notes to see if there was anything else that he may have not mentioned. Yeah. So yeah, that's about it. Other than I see a question from Becca about plans for including support for happy scripts. And the answer is yes. We coincidentally had a meeting with Jeremy Faden this morning to talk about he's going to work on a new proposal to do exactly what you are asking about here. So we will support that. It's just probably going to take time to develop and implement. So that's something we're looking into. Other features, of course, we're hoping to, well, future goals include an API. And we're going to include, of course, more data sets. Right now, the site is limited to mostly NASA or all NASA and some ESA. However, we're talking about including all repositories for which we have data. And then also we'll be kind of fine tuning the data to make it the old data space records to be more FAIR compliant. And maybe if data is missing a specific data element, we'll be adding it and things like that. So we're working on that. Interlinking relevant papers and software tools, that's on our list. And of course, improved mobile support. And so these are just a few. We welcome feedback from the community. So you can email me directly, or there's a contact us button at the bottom of the page, our site. You can use that as well. Either way, it comes to me and or Wally. So we do welcome feedback and are willing and flexible to do whatever would help the community with this site. So does anyone did she say December 18th? I said December 15th.
Thank you.
Yeah. So that's the first day of AGU. So we're doing it to coincide with that. Yeah. Yeah. So does anyone have any other questions?
Yeah, I've got one here. I'm curious to know how you all detect when URLs change for the data source, and if you have any metrics on how much of your time you spend updating broken links.
Well, we have talked about a script that would run through the data and find broken links. We have done that on a small scale. We have not done it on a large scale, but the ultimate goal is to have something like that in place that is a routine, weekly, monthly. I'm not sure what the how often. Do you have a suggestion? Are you do you currently do that with the site? Do you suggest weekly, monthly?
I'm not sure that I have any suggestions. Just having spent a lot of time as a data provider, I know that tends to be the biggest headache that comes up is data moves around unexpectedly. So I was just curious.
Yeah. It's on our list to we just haven't implemented it yet. So
It's nice. Yeah, that makes sense. I guess you guys are still in development. And also, yeah, sorry for any background noise. I'm boarding a plane.
well, safe travels. Normal. Don't.
Oh, I'm side commentary, unrelated.
Broccoli. I was like, "Ooh, I'm having broccoli for dinner tonight." So, what a coincidence. Any other questions?
This is John Vandergriff. Yeah, I'm glad to see someone else asking the question about Happy instead of me. But yeah, that was going to be my question as well. Are you going to support other access methods?
Yes.
And another thing that we found with the access part with Happy, a lot of times what people want to do is they know what data source they want, and they just want to know quickly, did this data set have data at my time or times of interest? So that's kind of just a generic comment like that. That's a kind of exploration activity. If you can support that, you might get a lot more interest. Like, okay, here's my specific time. Do we actually have data from that? How quickly can I get to the answer to that question? So that's
Hi, John. I can actually answer that. So one of the tools we're working on right now is a date range tool. We basically looks at the data sets in a specific date range, and then you can set that date range and then kind of filter through what exactly you're looking for using missions, instruments, um, measurement types. So yeah, so we're definitely working on that.
So are you planning to catalog the availability information for each data set so that that's kind of an independent lookup? Like, did this data set does it have stuff here? Can you determine that like very quickly? Maybe you just create a massive list of good time intervals or data present intervals or
Oh,
something.
actually, if you have a bit of time, I'm on my other laptop right now, which has that. I can kind of show you what we are thinking of. But I would need to connect this laptop. If you can just give me like 2 seconds.
I'll defer to Julie whether we have time for that, but yeah. Um,
Yeah, let's go ahead and get this question answered.
okay. Thanks, Julie.
You can carry on. I just need to connect. It might take a while.
While you're doing that, I don't know if you can think and type at the same time. If so, you've got me beat there. But uh, the do you have a data format, or are you planning on like capturing the availability info? That's kind of part of my question because that could be a useful thing to other efforts as well. Or if you have a way to store that we could standardize or leverage, that would be interesting too.
Can you give me an example?
Sure, like the MMS.
This meeting is being recorded.
Whoop.
Some missions only take data during specific intervals. So sure, it's orbiting the Earth, but they only took data inside the radiation belts.
Mm.
And so they have very specific intervals where the instruments were in certain modes that were interesting to people. So, sure, it goes on for 10 years, but it's actually only like, 5% or 20% present.
Mm. Mm.
Or the solar instrument that you want was one of many, it wasn't always on, or there's different intervals. So capturing that for a data set, here's the places when it's actually present with
Mm.
the start and stop time is 10 years, but the data itself is only present in specific episodes or intervals.
Mm. Yeah, that's we can talk about a future feature. Right now, I don't know if that data is captured in space at all, which is what we use
Definitely not.
to derive the site. But uh, yeah, but we could probably. I'll take note of that. And
Yeah, it's just if you start looking at that, let me know because we're thinking about doing that too, right? That if you had access to a data with a standardized mechanism like Happy, of course, I'm going to talk about that, but then we thought about making a script that scans through an entire data set and generates that availability information. And so we'd want to capture that in a way that, yeah, other people could use. Um,
oh,
and so if you start doing that, then, um, let us know.
okay.
John, I think what you can already do with this site is you can make a plot of that time that you're interested in. And if there's no data, it'll show no data.
Right.
But that's a crude way of doing it with what they have right now.
Yeah, it requires you to actually access the data or attempt to. And sometimes if you just get back nothing, that's not enough information. Like, well, did the request fail or is the service down or why is there nothing here? Getting a definitive statement that says there is no data for this time and getting to that quickly, that's often people's first question. Did they see my event? So anyway, I'm just thinking out loud, but yeah, this is cool.
Yeah. I mean, if you start exploring that, let me know, and then vice versa.
Okay.
Yeah. Okay, I see a comment related to that.
Yeah, I'm basically just me tooing John there.
Okay.
The presentation is one thing, but like just honestly having some means of representing it that we can agree on would be awesome. Maybe a future call.
Yeah, a schema for good time intervals, or because there's a lot of missions like that where they can't capture data all the time, but they have this long start time, stop time range in the space record, but you know, you really need fine-grained stuff. So, yeah.
Sounds great. Okay. Any other questions, comments? Did we put the link to the chat to the site in the chat?
I'm not sure if it ended up in the chat, but he did say it out loud. It's in our notes. I'll go ahead and throw it in the chat if anyone is curious to look for themselves later.
Okay. And if you, I'll add my email to the chat as well. And if anyone has any questions or comments, they can reach out.
Sounds great.
And apologies again for my Zoom issue.
No worries.
Yeah. So, Wally, do you have anything else? Guess not.
Great. Well, on that note, we can go ahead and wrap this up. Thanks for giving us this update. It looks like it's really coming along, and I'm excited to see it actually be released officially.
We are very excited to release it. It's going to be a nice pat on the back for us, and then we will continue to fine tune it as needed. Yep.
Sounds great.
All right. Well, thank you so much. Enjoy your day.
Thanks, you too.
Okay. Bye.
Andres, without further ado, the Helio Foundation model.
Okay, so I am going to give a shortish version of the kind of like extended talk that I have been giving around, because I would like to create the space to take it, to go deeper, anything that you guys may be interested to talk about. So let me share my screen. Okay, you guys see my screen fine?
Yes.
Okay, so you may have heard about Surya Foundation model. This is an effort commissioned and funded by NASA's Office of the Chief Science Data Officer. So it's a little bit of a different beast in the NASA ecosystem, in that, it was commissioned to a group of people rather than competed. But there is a very strongly experimental aspect to it that necessitated a commission like that. And I was fortunate to become part of this effort. And this experimental aspect of this has not ended with the release. It's only starting. And so I think, one of the main reasons why I'm very appreciative of being able to talk to you about this is that, I'm trying to identify who is interested in being part of this experiment. So first, let me start with the team. We have quite a bit of people in the team. Lika Gudhatakurta has been instrumental in making this happen in the way it has happened. And there are two main engineering institutions. So the heavy lifting when it has come to writing and training the model has happened at NASA Marshall, the Impact Group, and at IBM with hardware provided by NVIDIA. But we have a science core that has people from 12 different institutions across the United States, covering like as much of the heliophysics science as we could. And so, what you're going to be seeing is the result of this collective effort. So why this? Why a foundation model? It addresses several, as a potential way of addressing some of the needs that the scientific communities are having across the board. One is duplication, right? So in this moment, when we do science, we go to a data provider, we download the data that we need, and we analyze it in-house. And so this kind of like makes it impossible to have complete duplicates of the data to do any or all analysis. We cannot, not very many institutions in the world could duplicate the JSOC repository in-house. And so, it's a challenge that we're trying to address in many different ways. AI at this scale and coupled with big data is expensive and it's something that is out of reach of a lot of the heliophysics community. And so, there are different ways in which we can try to address accessibility, but knowledge distillation through AI is one of them. And so the idea that we can train a model that is multi-purpose on a wide cross-section of our data such that any person can reuse it without the need to have access to the data that the model was trained on. And when we were designing this project, we all agreed that, as the biggest AI project in heliophysics, there was an opportunity to build common AI infrastructure that people could use regardless of whether they are going to use Surya or not. So this includes code, but it includes also transfer of knowledge and development of knowledge and protocols and things like this. So, that having a model trained is not the end goal for us, but elevating the way the heliophysics community does AI is. So the things that I would like you to remember from this, to take from these presentations, these are my conclusions. I like to always to start with my conclusions, and also will structure the rest of this talk. The first one is the foundation models are models that are trained on vast data sets so that can be applied across a wide range of use cases. The definition of a foundation model is not very hard, and is not like, it varies from context to context, etc., etc. But for us, is big models, lots of free parameters, big data, and reusability. In this particular case, Surya is pre-trained using SDO data, so it's a Solar Dynamics Observatory Foundation model. The architecture that we're using is transformers. So these are the architectures that are formalizing the idea of relationships between data, and is validated using a range of downstream applications. Now, our preliminary results suggest that Surya is competitive when fine-tuned. So all our baselines, Surya is competitive. So that is one of the things that, like, minimum things that we wanted to achieve. Now, there are some super intriguing results that are very compelling in terms of the ability of these models to learn physics, but they're kind of bittersweet in that they work for solar cycle 24, which is where we used to pre-train, but they don't work for solar cycle 25. And so that's kind of like one of the things that is at the same time exciting. If for a second we're dreaming about the Holy Grail in our hands, but I guess more work is necessary. Now, as I mentioned, the value of our project, we're hoping that our value of our project is more than just having trained Surya, but the creation of this infrastructure, and I'll talk about that. And so any person that wants to be part of this, we're looking to connect with any person that wants to be part of this experiment, especially in this part where it's not a done thing. Surya is pre-trained, but we don't know exactly the boundaries of its capabilities. And so people that are interested in putting these things through the grind and finding the boundaries beyond which is not applicable are super, super welcome. So let me start with foundation models. A brief introduction. I can go deeper if you guys want. I have content, but later you'll tell me how deep I want to go in different aspects. So when we think about AI, I think the most powerful way of thinking about AI for me is that of a mathematical approximator. So if there is a mathematical expression or connection or a statistical distribution or a mathematical operator that you want to approximate and that you believe that that connection exists even though it's intractable or out of your reach, but that is contained within data, then AI can do it for you. And that is a very, very, very powerful thing. So you have data and you want to connect an input and a data through a mathematical transformation. And so you can approximate that as long as you have two things. A differentiable model. This is a sequence of mathematical operations that will transform your input space into your output space. They have to be differentiable and they have to have a learnable component. And a huge part of the revolution that we're seeing in AI is the cleverness with which humans have designed models that are increasingly effective at approximating almost anything that can be approximated mathematically, like language, for example. And you have to have an optimization function that informs your model of your priorities. So that's one of the objectives. And second, allows it to quantitatively determine how good your approximation is. Okay. Now, I personally like to think, even though this is not exactly canon, it is powerful to break the differentiable model into pieces. So it's not just a single box, but it has elements inside it. And at its simplest form, I like to think about this as an encoder. So this is a part of your model that maps your input data into a space. This space that we call the latent space or the embedding space is a very interesting space because we do have control over it, and is where all the knowledge distillation has happened. So, and then you have a projection head, which is a part of your model that takes your embedding space and projects it into your objective, into your application. Now, the challenge for a long time was the idea that you had to have this connection between input and output very well mapped. And the quality of that mapping will affect the quality of your approximation. And so that introduced a human bottleneck, because only the human will be able to curate effectively the mapping. But in the last decade, we have become very proficient at something called self-supervision, which is the establishment of tasks that don't necessitate human curation. So instead of having input and output data, you now work with input and input data. So it's both your input is your output. But you have something that is called a pretext task, which is not a trivial task, and it's meant to force the model to distill knowledge. And I will tell some examples in just a sec. So now that when you remove the human bottleneck out of the loop, you can train these models and pre-train these models and in vast and obscene amounts of data. And now your computational resources are the bottleneck. But we have a significant amount of computational resources now. And so, that enables the existence of models that are extremely compelling and effective and superhuman in their performance. And the objective here is that once you have pre-trained a model, you can freeze your encoding, take advantage of your latent space, and project it against a wide variety of downstream tasks that necessitate much less human labeling. And so that is kind of like at the core of the aspiration of a foundation model, right? So GPT, I think I don't remember what the G stands for, generative pre-trained transformer. It's a foundation model in that it was trained to build an understanding of language. But ChatGPT, which is the conversationalist bot, the one that satisfactorily chats and interacts with humans, is a fine-tuning application. So you pre-train with an incredible amount of text so that the model understands language, and then you use human interaction to fine-tune it into something that can talk or have conversations with humans. So Surya is pre-trained using SDO, a transformer architecture, and is validated using a range of downstream applications. So our self-supervision setup is the following. Our input data is full resolution SDO data at the scaling of AIA. So it's 4K by 4K AIA field of view. We're using 12-minute cadences. It's the whole mission, although in this moment for the first release, we only train on 2011 to 2019. We have the eight AIA channels, which are the 7 main channels plus say 1600, so 94, 131, 171, 193, 211, and 304. And HMI vector, then HMI Doppler, and HMI line of sight. Now we're using what is called a visual transformer. So very quickly, what makes a transformer so powerful is the concept of attention. The idea that your data, any part of your data is connected to another, and the purpose of the architecture is to find those connections. They were developed in the context of language, with the idea that in a sentence there is relationship between the words that don't necessarily are related to position. So yes, when I say I drive home in my car, there is a clear positional information there. When I say I drive home, there is like, in the English language, position is very, very important. But not all languages have that dependence on positioning as English does. But there are things, that you can infer. The fact that you're driving home may be related to the fact that you're done working, etc., etc. And it starts building relationships between words that are not immediately adjacent. So the transformer was a way of establishing relationships, and many different kinds of relationships between pieces of data that are not necessarily spatially adjacent. So that is different than the way we used to do computer vision before, in which we were kind of like the workhorse of computer vision was the convolutional neural network, which in some sense was built on neighborhoods. The idea that adjacency was very important, and we can build distill knowledge based on adjacency. Our pretext task is autoregression for the first release of Surya. This means is the equivalent in language as predicting the word that comes next. Twinkle, twinkle, little star. So what will be the next one? Maybe it's the song, How I Wonder What You Are. So it's all as you give full information and predict the future. So that is autoregression. Is one of the main pretext tasks that people use to train foundation models. The other being, and we're working on a second Surya release, mask augmentations. You have a sentence and you remove some random words. Which words are those? That is another very powerful pretext task. And we're using standard mean square error as our optimization function. So how the error on the future gets averaged, and that gets back propagated through the model. Now, when we were deciding how to do the first generation of downstream applications, we sat down with Lika on ADS and we were like, okay, let's look at everybody that has used AIA in their abstract or HMI in their abstract. And ADS has it has a kind of like a cool way of analyzing the results. So we look at citation networks. So these are the keywords associated with the different citation networks of AIA and HMI. So you have space weather forecasts, of course, but there's coronal holes and solar wind on AIA, but you have flows and magnetic fields in HMI, etc., etc. So when we were choosing our first round of downstream applications, we wanted to address as much as possible those different communities. The other one was we wanted our downstream applications to be like a bridgehead for the community. So mechanically, from a mathematical standpoint, in terms of, the dimensional space of your input and the dimensional space of your output, we also wanted to address those so that anybody could work on adjacent applications already with a template. So we have 1D classification. So this is based on the input. Is there going to be a flare in the next 24 hours? Yes or no classification. 1D regression. So we have solar wind forecast as 1AU based on the input stack on the solar side, what the speed of the solar wind is at 1AU in the next days. The ultraviolet spectrum. So the input is the stack of AI images and the output is the EVE spectrum. K-index forecast. In 2D classification, we have segmentations, applications. So if I give you an image and you tell me which kind of structure each pixel belongs to. Is this a coronal hole? Is this quiet sun? Is this active regions? So this is 2D classification. 2D regression is our pretext task of time advancement, image to image conversion. So I give you stacks as an input and you give me the future. So that is an image, like a 2D regression. And active region forecast as well. And then the more experimental ones, to me, some of the most interesting ones, but they're also the hardest ones, is a 3D regression. So can you go from the 2D image stack to a 3-dimensional assessment or estimation of coronal field or magnetospheric structure? So those are kind of like the ones that we choose. So our preliminary results suggest that Surya is competitive when fine-tuned and is learning physics, but performance is not the same for solar cycle 24 and 25. I want you to remember that, but I'm not going to go into a lot of detail right now. I didn't want this to drive completely my presentation. But if that's what you guys want to hear, I can talk about it for a while. So at the end, you guys will tell me where to go. Okay, right now I'm just going to focus on our baselines. So the good news is that downstreams, our first generation of downstreams, which is a subset of the ones that we chose initially. So this one, flare forecasting as regression and classification, solar wind forecast, EUV spectrum, segmentation, and our time zero shot, kind of like pretext task of time advancement. In all of them, Surya is competitive. So this is not something that we have specifically looked to see if it outperforms any other applications of AI or other methods, etc., etc. We just wanted to make sure that a fine-tuned Surya can do well enough, or within the skill score of other applications. And it's true for all of these. So I can go into detail into any of these, but right now, I'm just going to tell you that it is, the metrics, when any other applications of SolarWind forecast that we had, Surya does at least as well, if not better, etc., etc. Now, better by 5%, 2%, so it's not like wow, but one of the objectives was flexibility and the fact that it's multi-purpose. So that is definitely something that seems to be the case. Now, as I mentioned, we're working with a secondary release that will have both cycles for training. It has more augmentation. So augmentation is a way of showing an AI model the things that you don't want it to care about. Now, we decided, because we had finite computing resources, that we will work with 24 without augmentation and then test on 25th. This was, deliberate. The idea that, how applicable this is outside of its training period. And so right now, the answer is no. At this level of knowledge distillment, is necessary to include also as much as possible, and augmentation will be necessary as well. So this, extends the training period that we did before. This one uses a pretext task of mask augmentation. It will have a module to do time advancement, but this is trained as a secondary component, not as the dominant component as in the first release. Now, for the scientific community, the value of our foundation model goes beyond our ability to train this model. And so we have taken some steps towards making our infrastructure reusable, and mainly in the form of guides. Our pre-processing pipeline builds on top of SDOML. And then we are building step-by-step fine-tuning guides with examples and templates that will also allow someone that has not experience with AI to follow the best practices. We have worked without the differentiable metrics. So if there are, we have worked a lot on writing some of the things that don't exist in PyTorch so that you could use them as a loss that backpropagates through models. So we have we wrote things for flux, total unsigned flux, signed flux, etc., etc. And we have been working also, and you guys have heard me talk about this on the site, on coordinate transformations, but in PyTorch, so that you can either use them to do things at scale in GPUs, but you could also backpropagate to coordinate transformations with the same functionality as SunPy. This is something that we don't have completely written, but the idea to have also uncertainty estimation as part of the template. And then, packaging that data and metrics to create the benchmarks for the different downstream applications. And all this is kind of to exist in an overleaf template, kind of that as you do the process of fine tuning, you can report into that template, follow the guide, report your results, and be closer to a publication. Now, the last thing that I wanted to mention is that, as I said, we're looking for help shaping this project and this model and share ecosystem the best it can possibly be. In particular, talk with me if you have any questions or anything. But we will have a workshop to do fine-tuning applications in January. And I can talk more about that, but I will encourage any of you that is interested in something like this to apply. So the idea is that the first day of the workshop will be informative, largely informative. The majority of it will be what is Surya, how it was trained, what is it for, how do you build the downstream applications, some of examples of the downstream applications that we have, etc., etc. But we're aiming to have around 20 projects for a hands-on. So if there is a project that you want to do and want to spend 3 days hacking at it, so the next 3 days are hands-on. We'll start with baselines, then we do fine-tune, we build data loaders and data sets, then we fine-tune Surya, compare against our baselines, implement our metrics, compare our baselines, and then do a final presentation of all the different projects. So if you're interested, you can go to heliofm.org or look at this QR code or ask me. There is like a form that we're asking you to fill to understand what people would like to do, whether you're interested in the hands-on or not, and then to start kind of like identifying if the application is a good match for the workshop or not. Okay, so now for the last 20 minutes or half an hour, depending on how we are in time, I just wanted you to now choose your own adventure. So there are several possibilities. One, if you want to know more about transformers, I could go into that and explain how a transformer works, why it works, what is the logic behind it, etc., and basically the innards of Surya. If you want to see our super exciting but bittersweet flare evolution results, I can go into that as well. If you want to go into more details about any of our competitive baselines, I can also go into that. If you have any questions about the workshop, I can go into more detail into the workshop. And if you want to hear about, more exotic and experimental and potentially complex applications of Surya, I also can go into that. Or anything, if anything that you may want to ask that is not part of this menu.
While people give their thoughts in the chat, I see Rebecca, you raised your hand.
Hi,
And Julie,
Andre.
can you please, sorry, Rebecca, give me just a sec. I cannot see the chat, so can you please keep an eye on the chat?
Yeah, sure.
Okay, sorry, Rebecca. Thank you.
Hi, Andre. Nice to see you again. Good talk. So I've been exposed to the Surya model a couple times and even had a time where I was listening to those conversations in the DASP office, program, not office. And the conclusion I'm forming is that this model is not ready for science application. So the not problems, maybe that's a strong word, but the things that I'm seeing that are troubling is that there's the validation that's being performed with the model is covering the same data it was trained on. And that's basically saying if it remembers, sorry, seems to me that's basically saying, do you remember what I trained you on? And can you just regurgitate it? That's not typically what we do for model validation. Are there plans to, say, do validation using other solar imagery data, maybe external to the SDO, since that seems to be the data set that's being used for training?
Oh, I see your question. So a transformer is kind of like built on the idea that you construct a visual transformer like the one that we're using. Is part of it is built on the idea that you're creating a language, like a visual language for the data that you're using. So if you can imagine, it works by tiling the image. And if you can imagine all the images from SDO, how many individual blocks do you need to be able to create any solar image? Those are a smaller amount than all the individual tiles we have ever seen. Now, the fact that the visual transformer is aiming to build kind of like a visual language, necessitates the fact then that when you deploy it, it has to operate on the imagery that you train it for. And so you cannot immediately apply a foundation model you build using a visual transformer on a certain type of data to others without additional work. Now, we do have and are going to explore fine-tuning applications that act as translators. So you can actually attach trainable components to create tokens like the visual language or translations between the visual language of SDO and other missions. So one in particular, one of the ones that we had in-house, that we have in-house, was stereo, to stereo and SDO. Now, when people do multimodality, in that you start combining things like language and images, then there are different ways of going around this. But for me, a future in which we start integrating more instruments and so on will require training additional models. So there are many ways you can train a model with everything at the same time. That was beyond the scope of both the resources and time that we had. Or you can train models like, in my mind, what I'm thinking is, can we start creating models like Surya that produce their own tokenization, their own language, and then you can deploy attention across them. So that's how the way people mix image and text do. And so in that context, obviously there has to be a limitation on the scope. It cannot, not on the first time of our first try, we're going to try to do a foundation model that connects everything with everything. And so we started with SDO, which was the richest and most homogeneous form of data that we had. Now, your question could be interpreted as in that we were not careful in the split of our validation and our testing. I just wanted to make sure that that's not what you were implying, because we were not. To the point that we actually looked at logs to make sure that no file on our test sets were ever accessed during the pre-training period. So, we can talk about splits and testing, validation, training splits, but we were extremely careful and disciplined with both. And the fact that we trained it on 24 so that we could deploy it on 25 was part of that too. So that is, I think, the two things that I wanted to say about that.
Okay, so then including that that carefulness that you mentioned in the Surya presentations, I think that's going to be a critical step in increasing the acceptance in the community, because every ML or AI presentation that I see, they are very careful to describe the split of their training data set and their validation data set. And I've yet to see that in any Surya presentation. It's always trained on the full solar cycle, and here's our validation on the same solar cycle. I'm like, that's not how we're supposed to do things, guys. I'm not an AI person, but I've been in a lot of those presentations.
I'll make sure. Yes.
Yeah, that would really help. Last question, I'll hand it off to other people that might have software questions. So there was a paper a few years ago by Mike Lemon, one of the modelers that I respect in the community, and he did the whole paper about metrics for model validation. And this is one thing that I think would also increase trust for the validation of Surya. So you have this, what was the acronym? The mean square error as the optimization loss function. So using the same metric in validation is probably just a repeat, but if the other metrics and I put the link to the paper in the chat. If the other metrics in there could be actually used in those validations to calculate what those metrics are for this example versus this one, for instance, I think that would also help. I believe the name was Suter Orr. He gave a presentation at Dash on the Surya model, and the validation that he showed was very qualitative with no metrics, and it wasn't it didn't carry over well.
So
Maybe the
each
group
one of
should
our
consider that.
downstream applications, and this is depending on where people want to go right now, we can go into that. So MSE was the loss that we use for training, but we had specific metrics for each downstream. So when we were doing flare forecasting, we will use, the metrics for classification, binary classification. So those are the ones that 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 are specifically tailored to the application. But for the pretext training, we were using only mean square error. So each downstream application has its own complexity and sophistication, and each downstream application, not the same metric. You will not use the same metric for flare forecasting that you will use for a regression, or and so each one of them has their own metrics, and those are the ones that we use to compare baselines. Now, there is something you mentioned that I wanted to also clarify, that Surya is not ready for science consumption in that we don't understand well the outlines of what it can and cannot do. And so I was having a conversation with Robert Jarolim the other day, which I think is maybe a misunderstanding in the communication from our part in this moment. And there are people that are interested in putting the model through the ropes.
Yeah.
Right. And we need that. We pre-train it, and the pretext context has very compelling results. Within our in-house, the downstream applications, the ones that I show you, and in all of them, we're competitive. But what we need in this moment is people that are willing to give it a try, that is not us, that are willing to be taught how to use it and train it. And I'm especially interested in applications that actually get outside of the fine-tuning, the pretext task. So, for example, when I talk about this in APL and John Hopkins, there was a person that was very interested in finding coronal jets. Coronal jets are very small-scale reconnection events that dump plasma into the solar system. These are very fast events, kind of like beyond our pretext task training of 12 minutes. But they are like super numerous. They're happening all over the corona all the time. And so I find that as a fascinating fine-tuning application is, can you use the tokens that Surya is producing? Because it has seen jets, not a single jet all through its lifetime, but millions of jets at every possible inclination, every possible orientation, every possible location of the corona, and at every possible stage of their lifetime. Was that sufficient to power a jet segmentation, or a jet identification downstream application? And so these are the kinds of things that are not, we didn't choose them, but if someone is willing to give it a try, we can see. And I think that the hope is that those downstream applications that work, great. They work, they have a publication template, their authors publish that. But every application that doesn't work, we collect them into a negative result. All the things where Surya didn't work. And what are the lessons learned? What does that imply about the pretext task? What does this imply about the architecture and the design of the pre-training effort of Surya? So I think that's kind of like where we are. After that, I was telling Robert Jarolin, the talk that I will give at the AGU this year is not the same that I will give at the AGU next year. When I give you the talk next year and I tell you where it works, where it doesn't, where does it break and why, that I will say is a Surya that is ready for science consumption. But in this moment, we are in need of experimentation before we understand when and how we can trust it to be applicable in science.
Did you bring this to the Shine group?
To the Shine group?
Yeah, the solar physics and helio.
No.
I highly recommend it. I'll put the link in the chat, but I'll hush. I've taken up too much time.
Hey, Andres. So John Vandegraaff had a question. He unfortunately had to jet, but I'll write it down for him so he knows. He was asking about the workshop. Two questions. Is there travel funding available for participants? And then what's the target number of attendees?
So there is no travel funding for participants. There is going to be, the main in-person component will be here in Boulder. But as far as we have for people that have shown interest in the workshop, the majority of the participants will be online. Okay. We have considered the possibility of having in-person components in the Bay Area and in the DC area. But it depends on how many like hands-on people are interested in being part of the workshop. Now it will run between 8, so every day it runs between 8 a.m. Pacific and 3 p.m. No, 4 p.m. No, 3 p.m. Pacific, yes. So it's between 8 a.m. Pacific and 3 p.m. Pacific, which is between 11 a.m. East and 6 p.m. East, with an hour and a half for lunch. So we're kind of like, so that it serves as all our time zones in the United States, at least as comfortable as possible. So all things are looking like, it's more, it's a hybrid with the strongest presence being virtual.
Gotcha.
And, there is an informative, sorry, I forgot to answer this other part of the question. The informative component, which is the first day, where you will see why, how, and how to use it as an informational component, are open to anybody, and there is no limitation about how many people we are going to serve. The hands-on components, we are ballparking 20 hands-on downstream applications. That is because we need to ensure that there is compute to go with it. And so right now we're looking to run it either on AWS or in the Google Cloud. And that is the main thing that puts the limitation on. Well, there are several things. One is resources, so computational resources. The second one, of course, is our ability to serve the participants. The hands-on component will be, people working on, it will not be like a hackathon. It will be, okay, we're going to do this now, and this is what you need to do. This is your task. And then next we move into this, then next we move into this, for the majority of participants. And so our ability to serve, so many people, if they have questions, if they need help, etc., it's also limited. And so that also reduces the number to 20. Now, if we have very advanced, this is more catered to people that are learning, I think, than hardcore AI users in the community. So this is kind of like a class. But we have people that are interested, that are pretty actually advanced AI users. For them, we're considering running theirs as a hackathon. So they will not have to attend, what is a data loader, how do you build a data loader, what is important when you're building a data loader, and how do you test it. They probably already know how to do all these things. So for them, we may run it more like a hackathon. 3 days, you have resources. We do a touch base every day at the end of the day. Where are you doing? What are your challenges, etc., etc. But they're more freeform. But personally, the people that I would like to serve first are those that are kind of like intrigued, interested in taking the first steps in AI. That was one part of the thing. And so take them through all these things that are guided. Now, if there is like a lot of interest, or we want to do another one in Europe, or we want to do another one next year, we can definitely see, depending on how successful it is and interest, we can do that. We will also record all the sessions and turn all these into like a Coursera kind of thing, where you'll have a lecture and an exercise that you need to run with the templates, and you could do it on your own compute, on your own time as well. So that's also part of the goal.
Gotcha. Sounds great. Do we have any final wrap-up questions for Andres? All right. Well, thanks again, Andres, for your presentation and hopping on our call.
Yeah, my pleasure. If you have any other questions, you can let me know.
Okay.
Please check the chat before you go.
Oh, yes. I was not going to drop out. I was just going to stop sharing. But yeah, I'll check the chat.
Yeah, Rebecca put a link to Shine in there for you to take a look at. For the rest on the call, we'll come back same time, same place tomorrow. Sean will kick us off with some of the AI work he's been doing within PyHC. We'll have a big discussion surrounding the various FEPs, review of FEP1 and so forth, and then debrief. Thanks, everyone.